Hey guys, I'm gonna get that Carol Baskin. I just watched Tiger King, and she definitely fed her husband to the tigers. 100% did. I don't care. You can say I'm smoking meth or whatever. I got my Tiger King shirt on. I got my guns. And we're here to answer the question, what drops first? The bullet that's fired from a gun or the bullet that's dropped from the same height? You know that bullet that's fired from the gun is going to go a long distance in the X direction. It's going to go horizontally. The one that's dropped is just going to go vertically down. Both are pulled by gravity. Which one hits the ground first? I'm going to show you. Carol killed her husband. Guarantee it. Here's that again in a smaller scale. I have here a device that's gonna drop a ball bearing straight down and shoot a ball bearing off to the side. Let's see which one hits the ground first. They are the same mass. Let's do it. Same time. Why? Because the only force acting on them after this leaves this and this leaves that, there's only one force acting on them, and that's gravity. Pulling down at the same time. It doesn't matter that this one has a horizontal velocity, their vertical velocities are the same. They're accelerating at 9.8 meters per second squared because of the Earth's gravity. It's the same. Hey guys, it's Tiger King here. Mr. Jenkins, and I'm going to tell you exactly why what you saw happen just happened was the bullet that's fired and the bullet that was dropped hit the ground at the very same time. I'm here to show you why. Now on the message board, the predictions that you guys had, I think a couple people got it right. Demaya got it right. I think Joe Amaya got it right. Miguel Villarreal got it right. They hit the ground at the very same time. Some people said that this bullet would hit the ground first because it's traveling faster, and some people said that this bullet would hit the ground first because it has less distance to travel, but all that is wrong, and I'm going to tell you why. The secret is to understanding what happens right after I shoot this or drop this. There are two things going on, and we can think about them on a graph. In the X direction, which means horizontally, and in the Y direction, which means vertically. Now, let's talk about this direction first, the horizontal direction. The first bullet shoots, right? So it has a vertical velocity. It has a velocity going this way, and let's say it's 10 meters per second. Its velocity is 10 meters per second that way. But as it goes this way, it's also going down. I hope you see that too. It has a horizontal velocity as well. So it has a vertical velocity and a horizontal velocity. Now, let's look at those. Look at the vertical velocity of 10. After it's shot, is it ever going to get faster? No. It's never going to get faster than 10. Never, never, never. It actually might get slower because it's going to hit the air and the air is going to slow down. But this velocity, right, only applies in this direction. This velocity is going to carry out until something stops it, because objects in motion want to stay in motion, objects at rest want to remain at rest. What Newton's law is that? So this direction right here is completely separate from what happens in this direction. And when we're talking about gravity, all I care about is this up and down direction, because this force works up and down on our world, right? So going down, you should see that it accelerates at 9.8 meters per second every second. It doesn't stay constant, it changes because it's accelerating, its velocity is increasing if I drop it. Everything that falls, you see me drop the heavy Coke can and a light Coke can, they fall and they hit the ground at the same time. Why? Because gravity acts irrespective of any of that. Gravity acts on everything in the same manner and it accelerates everything at 9.8 meters per second squared. So this that's fired, this dart that's fired, yeah, it's going to go really far, but it's going to fall at the same rate as the one that's dropped. Now let's look at the one that's dropped. The one that's dropped goes straight down. It has a vertical velocity of 9.8 meters per second squared, an acceleration, right? So 9.8 meters per second in this direction, but in this direction, it has nothing. It doesn't go anywhere, but it has the very same vertical velocity, acceleration of 9.8 meters per second squared, increasing as its fired counterpart. So they will actually fall in this direction at the same exact time. The only difference is this one will also have a vertical or a horizontal velocity. It will also have a horizontal velocity. Now the trick is to think about these worlds, or these two things, in two separate worlds. We have our horizontal and we have our vertical. Gravity acts vertically, right? A force acted on this object that was shot, and yeah, it gave it some horizontal velocity, but there's no force acting on it after that, right? It's not a rocket ship that keeps propelling itself. It got hit, and then it's going to keep going until air slows it down, but gravity's acting on them in the same way. They hit the ground at the same time. I'm going to link to you an activity, multiple choice this time, thank you Val, about this activity. Answer it, and then watch the Mythbusters video right after this. So, thanks.